how many liters of pure disinfectant must be added to make a solution that is 60% disinfectant. Notice that in this case, the nurse has 150 liters already mixed up. The 150 liters is 50% disinfectant. The nurse wants something that's stronger, 60% disinfectant. Does it make sense to you that the nurse would add pure disinfectant to that? Surely the container of disinfectant should be opened and poured into the container of the solution, but not just dumped in. To get 60% disinfectant, the nurse must know how much of the pure disinfectant to add and measure it out. Well, let's go to our chart. Amount times unit value equals total value. Amount times unit value equals total value. This across the top. We're mixing two things this time, 50% solution, pure disinfectant, and 60% solution. 50% solution first, pure disinfectant to be put in with it, and then 60% solution. Notice the 60% solution is actually the mixture, a mixture of the 50% and the pure disinfectant. But I'm writing the 60% solution here since that's the level of strength needed in the mixture at the end. Let's fill in the numbers. This nurse has 150 liters of the 50% disinfectant. So the amount of the 50% solution is 150 liters. And let me put above this, the amount is in liters. The unit value, 50%, is written as a percent. Just as we did with investment problems, the percent is always written in decimal form. So we write 50% in decimal form, 0.50. The next number we see is 60%. The 60% is the new solution. We have it labeled here in our chart, 60%, and so the 0.60 in the unit value for that one. Now you realize that we have only three numbers this time, 150 liters, 50%, and 60%. Those are the only numbers that are printed out in this problem. So that means we'll go to our system of equations now by filling in the blanks, and we must put in some letters or other numbers or combinations. Well, for the pure disinfectant, we don't know how much that is, so let's call that X. For the 60% solution, we can use Y. And then for the total value, we multiply 150 times 0.50, and we get 75. X, there's a blank here. Let's go down to the next row and see what we get there. Y times 0.60 would be 0.60Y. But there's a bit of a problem here in this second row. With our pure disinfectant, we have X liters. What about the percent? What about that percent? We didn't have a number printed in the problem. However, we are told that we're putting into this pure disinfectant. If the disinfectant is pure disinfectant, what does that mean? That means it has not been diluted. That means this pure disinfectant is 100% disinfectant. The pure disinfectant is 100% disinfectant. Pure means 100%. So our pure disinfectant was a clue that actually gave us a number without printing it on the page. Watch for that. How many liters of pure disinfectant? The pure disinfectant is 100% disinfectant. How do we write 100% as a decimal? 100% is 1.00 to 2 decimal places, or simply the number 1. Then, the amount times unit value equals the total value. X times 1 is 1x, or simply x. Now every space has been filled. Now we can write our system of equations. The 150 and the x together will make the y. The 75 and the x together will make the 0.60 y. And so here is our system of equations. 150 plus x equals y, and 75 plus x equals 0.60 y. You may notice that these equations are not in what is our preferred form. We'd like to have the x term, then the y term, then the equals mark, then the constant. But this time, look at where the x's and the y's and the constants are. They're out of order, but the constants are in the same position, the x's are in the same position, and the y's are in the same position in the two equations. And so we can rearrange things if we please to get them in the standard positions, or we can simply leave them in the order they are. It'll certainly be easier to leave them in the order they are, and so let's, as always, choose the easy way as long as it's correct. Let's eliminate the x. It's all set up to be eliminated, isn't it? So let's eliminate the x by multiplying the first equation by 1 and the second equation by -1. And this will give us 150 plus x equals y, and -75 minus x equals -0.60 y. When we add these equations, the x terms cancel, and so we get 75 equals 0.40 y. Now I have done this by hand, that is, y is 1y, 1 subtract 0.60 is 0.40. You can think of it as $1 subtract 60 cents would be 40 cents. If you type this on your calculator, you'll notice that the subtraction, 1 subtract 0.60, gives you simply 0.4. The 0 would not be there. We divide now by the coefficient of y, either 0.40 as I have, or if you use your calculator, you would not have these zeros, you would have simply 4/10. Dividing by the coefficient on both sides of the equation gives us 187.5 equals y. So the y is 187.5. This gives us an answer for one of the variables in our equation. Does that answer the question? The question was, how many liters of pure disinfectant do we add? Well, for the pure disinfectant, the letter we chose is x. We have just found y, so we must now go back and find the x value. And so back at our system of equations, we'll fill in the y value in one of the positions. I'm going to choose to use the first equation, which is rewritten here at the top of this sheet, filling in y, 187.5, and we get 150 plus x equals 187.5. Then to get x by itself, all we must do is subtract 150 from both sides. 150 plus x subtract 150 equals 187.5 subtract 150, and that gives x equals 37.5. So the x value for our system of equations is 37.5. The x is what we were after, and so 37 5/10 liters of pure disinfectant must be added to make the desired solution.